Hello, we're doing checkpoint 4.15. In this checkpoint, they want us to find the limit definition of the partial derivative of f, or partial of f with respect to x, for the function f of x, y, z that's given here. And then they want us to find the partial of f with respect to y and with respect to z without using the definition and essentially using the shortcut. So let's first recall our definition for the derivative of f with respect to x, which involves the limit as h approaches 0 of f of x plus h, comma y, comma z, minus f of x, y, z, and all over h. Okay. This means that for the first term in the numerator, we will look at the expression, and wherever we see an x, we're going to replace it with an x plus h. All right, let's begin. The partial of f with respect to x will be the limit as h approaches 0 of a big, long fraction. And that big, long fraction, we probably should move down a bit just so we can give some room for the work that we're going to do. And we'll begin by putting in those values. Okay, wherever we see an x, we're going to replace with an x plus h. We have a 2x plus h quantity squared minus 4x plus h quantity squared times y plus 2y squared plus 5xz squared minus 6. Oops, that 5xz squared has an x in it. Wherever we see an x, we're going to replace it with an x plus h minus 6x plus h plus 3z minus 8. So that is the big first term. We're going to expand this in a few minutes, but let's first write the rest of the limit down. The second part will just be the function as it is. That's 2x squared minus 4x squared y plus 2y squared plus 5xz squared minus 6x plus 3z minus 8. Okay. Oh, yeah, and we want to divide this whole thing by h. Now, when we're working this out, when we're doing these limit definitions for the derivative and we're dealing with polynomials, it's going to turn out that we're going to have a nice set of polynomials that we're going to expand out and things are going to cancel. So first thing we need to do is expand the first term in the numerator. And some of these will require some foiling and distributing, and we'll try to do that. I'll try to do that in one step. So the first one will be a 2x squared. So it's x squared plus 2h plus h squared inside of the parentheses being multiplied by 2. So this is our first term. Our second term has a 2xh with a 2, and that makes 4xh. And then our last term is h squared with a 2 in front. Okay, that's the first one. Now we have a 4, and we have to expand x plus h quantity squared and then multiply it by y. So we're essentially multiplying by negative 4y. Okay, so minus 4x squared y. That's the first term. The next term is 2xh times 4 is 8, negative xh, and then we have that y that we're tacking on. And then the last term is negative 4h squared times y. Okay. Now we have a positive 2y squared. That doesn't change. And the 5x plus h will get distributed. 5x plus 5h. And then the 6, oops, there's a z here, z squared. forgot about the z squared. So that's 5x. So let's multiply this by z squared. 5xz squared plus 5hz squared. Okay, now we have a 6x minus 6h and a 3z and a negative 8. Okay, that's the whole first term expanded, and now what we're going to do is we're going to watch out for the same terms with the same signs, because you'll be subtracting them, and with the subtraction we're going to cancel out a whole bunch. In fact, we're going to cancel out everything in the second term. So we get the negative 2x squared gone. We have a minus 4x squared y. That's minus 4x squared y. That's gone. We have a negative 2y squared. Gone. We have a 5xz squared. That's gone. Negative 6x, positive 3z, and a negative 8. All right. Now, what do we have left? What we have remaining should be a bunch of terms with h's in them. We'll take a look. We'll see that we have 4xh. We have a positive 2h squared. We have a minus 8xhy minus 4h squared y plus 5hz squared minus 6h, and that's it. And as we've seen, they all have h's in them. So we can write that as a limit as h approaches 0 of all those terms with an h in it. So we can cancel with the h in the bottom. And if we take the h out, we would have 4x plus 2h minus 8xy plus 4hy plus 5z squared minus 6. All the h's are gone. And not only are they gone, but they're going to get canceled out with the h in the denominator. And now we can take the limit as h goes to 0. And as h goes to 0, all the terms with an h go to 0. So what do we have left? It turns out the partial of f with respect to x will be whatever's left over. We have a 4x minus 8xy plus 5z squared minus 6. Okay, and if we take a look at this function and imagine taking the derivative of this thing by holding y and z constant, the first term will be 4x to the first power. The second term, if y was constant, would be negative 8x to the first power times y. The 2y term will be gone because it's constant, and we have a 5xz squared, and 5z squared would be constant, so that would just be a 5z squared. And we have a minus 6x. X is constant. The derivative of that is just going to be negative 6. 3z is constant, so the derivative of that is 0. And we have a minus 8, which is constant. So that's gone. So this is our derivative. Now, the way we just did the derivative that way was a lot easier, and that's how we're going to do the other two derivatives. So let's go ahead and do them. Okay, the partial of f with respect to y, treating x constant and z constant. The first term will be 0. First term will be 0. The second term, y is the variable, so the minus 4x squared is constant. And the next term will be a 4y to the first power. 5z or 5xz squared is constant with respect to y. That's also gone. Negative 6x is also a constant, and this is a constant, and then we have a constant. So our partial of f with respect to y simplifies to minus 4. Negative 4x squared plus 4y, and that's it. Okay, let's do one more. The last one is taking the derivative with respect to z. We'll have a 0 plus 0 plus 0 with respect to z. It's just going to be a 5, or there's a 2 here, so that's a 10x z to the first power. 10x z. And constant with respect to z, here we have a 3, and then that's it. So the partial of f with respect to z is just 10xz plus 3. Okay, along with the first one, we have all partial derivatives. And hopefully from now on, we just do these derivatives the shortcut way, and things will be a little bit easier. All right, I hope that helps.